Welcome back. We're going to be working on expanding our knowledge on built-in functions, statements, expressions, and all other things on variables. So we're going to get into it. We're going to do a lot of fun stuff. We'll be doing a lot of refresher at first, and then going a little deeper into all these things that we can utilize. So hopefully you were good with the last lesson. What is an expression? So an expression is essentially a piece of code that represents something. It doesn't necessarily have to do anything, but it does represent something. So examples of this would be like 2 plus 2, print hello world, or this is an expression as a string. These are lines of code that actually exist, but they may not actually operate or do anything. However, on top of that, you have statements, which would be an expression that actually does something for the application. Print hello world is an example of an expression as well as a statement. It does something, it prints hello world to the screen, as well as just being an expression itself. So for example, you could have a variable that says y equals this expression is a statement. That would be another example if you utilize that string. Lastly, you could do something like a conditional that is if x is greater than or equal to 2, and that is actually considered a statement. So that puts us in two categories. We have expressions that essentially are code and they're syntactically accurate, and then we have full statements that actually run something or do. So there's a ton of different type of expressions. There are constants, there's operators, there are variables, there's sequences, there's functions, there's classes, there's definitions, there's calls, there's all sorts of different things that are actually expressions. And the way we combine those expressions into statements, we can create some really cool programs. So if we want to talk about constants, constants are essentially built-in things that are constant. They don't change. They're hard-coded in there. So you have true, you have false, you have none, you have not implemented. Those are Python built-in constants. But you also have numerical constants, so like an integer or a float. Those we consider constant as well, as long as you are typing in the number and not utilizing a variable. The actual number itself is considered a constant. Beyond that, we have string constants. So every time we quote our strings, so if you do single quotes, or you do single double quotes, or you do triple double quotes, or you do triple single quotes around your strings, all of those are considered string constants. And they won't change. Those constants will stay static no matter where you type them at. When you apply them to a variable, you can change the variable, but the string itself is a constant. Speaking of strings, strings have these really interesting things that you can utilize called escape sequences. So there's a special character, the backslash is actually called an escape for Python strings. It allows you to put a character after that slash to represent something unique. So for example, if you do \t, it gives you a tab, or \n, it gives you a new line. So there's a lot of different characters that you can go into, or a lot of different escape sequences that you can utilize to create interesting strings. There's a lot of escape sequences you can use to manipulate your strings into doing the things that you want them to do and being represented how you want. So if we look at what our escape sequences are, so we have the new line, we have the regular backslash. So to one backslash would just be an escape sequences, but doing two next to each other actually gives you a real backslash. You also have a single quote. Because strings start with single double quotes, you would have to escape sequence a quote within a string. So if you wanted to quote somebody, you would have to do the string with quotes on the outside, and then inside, wherever you want to use a quote character, you'd use a backslash and then the quote. \r is a carriage return, \n is a line feed. Wherever you put this escape sequence in your string is where it's actually going to happen. So if you want to start with a tab, you would need to use your quotes or opening quotes for your string, do a \t, and then start writing your string. Then you're closing your quotes at the very end. That would actually give you a tabbed sentence or tabbed string for you to utilize. Now if you want to do it somewhere in the middle, you would just put that \t in the middle somewhere. So strings are pretty interesting. There's a thing you can do to actually slice them. You can cut into them. You can use a bracket and a number at the end of your string, and then close that bracket off and actually index into your string. Especially if you're using it in a variable or storing it into a variable, you can index into that string and get certain types of. You can cut up the string and get certain parts of it, and that's actually what we like to call a sequence. So there are other types of sequences as well. There are tuples, there are lists, there are ranges. These are all different types of sequences that Python has. Strings act very similar to these other sequences. Lists are represented by square brackets. You can utilize those to store information that is repetitive or sequences. It's kind of like a row on a spreadsheet. You can comma separated values across. Tuples are very similar. They're represented by parentheses and a comma in the center. Comma has to be there, or just represented as parentheses themselves, like you would do in mathematics. So you have to have at least 2 values in there separated by commas. Lastly, range you can create by actually using the built-in function range and actually create a range of numbers. But those are all essentially sequences that we can utilize to index out and build things with, or essentially different types of arrays that we can use. Speaking of parentheses and different type of brackets, Python utilizes operators, and we kind of used our operators last time when we did some mathematical formulas. There are operators in Python you may not be familiar with, but the precedence is very similar to standard mathematics. So, for example, of course, at the top you have your parentheses. Parentheses tell Python what exactly it's supposed to be doing first. Whenever you're doing an operation, it says, hey, start here, or at least condense this down or solve this part of the equation first before you do anything else, before you move on. Next, you actually have exponent. Exponents are represented by 2 asterisks side by side, so almost like 2 multiplication symbols side by side. You can utilize those to do any type of exponents. You would utilize that with decimal points or floats to do root functions. It's the same thing, just double asterisks. After that, you have your multiply, divide. You actually have your integer division as well, and then you have your modulus. So those are all in the same precedence level of operation that you would see. Asterisk represents multiplication. Your forward slash represents division. Integer division is represented by a double forward slash, and then you have a modulus, which is essentially your remainder, represented by the percent symbol. And then after that, of course, you have your addition and subtraction on the last level. And below that, you actually have your assignment operator, so your equal sign or your plus equal sign. Those things are actually come below the operation of addition. So all your mathematical equations will happen first, and then it will do assignment to your variables after that. Speaking of variables, that's where we're at now. So we utilize the equal sign to represent variables. And so we have on our left-hand side, we would have some type of name like we've talked about before, an equal sign, and then whatever you want it to equal. So if that happens to be a digit, like a float value or an integer value, if it's a string that we were talking about utilizing quotes, you can even be a function or a function call. You can actually assign it to an object or an instance of an object. There's a lot of different things you can actually assign a variable to. It really doesn't matter. A true, false statement, a constant, you can assign your variable to whatever you want it to be in Python, essentially. And it just has to be your left-hand side being your variable name, then an equal sign, and then whatever object or item you want it to be equal to. There are some other alternative assignment operators besides just equals. You can have a plus equals for mathematical operations, so you can take whatever's in your variable and plus equals to whatever's on the right-hand side, or you can do a times equals or a minus equals, and it'll actually essentially be like x equals x plus something. So it actually is a way to condense down your operators into an assignment as well. Now, I mentioned functions. So what is a function? What is a function? So a function to us is just something we do. It's an action. It's an operation. We function, we do something, right? And that's essentially what a function in Python is. A function is a group of statements combined together that can be called to be used repeatedly or multiple times. So you would create a definition of your function. So it starts with DEF. Then you would do a space, your function name, parentheses, and add any type of parameters you might take in for your function, and then you end with a colon, return, and you start typing out what your function actually does. We can show you an example of a function right here that just prints out your name. We'll get into functions a little bit more, but essentially what happens is your function your function definition has a name, and it has parameters outlined, and then it has its actual action. Then you have the second part, which is actually a function call, which is just your function name in parentheses, and then you fill it with any arguments that the parameters might take. Those are the two parts that would actually do. So you can see an example right here of the definition of a function, and then here you can actually see it being called. This is also a list of built-in functions that you can utilize. These are some of the most used built-in functions. So functions allow us to condense statements down to do something that might be, we want to repeat it multiple times, and we don't want to have a giant block of code repeated 4 or 5 times. So functions allow us to abstract some of our code and just represent it by the call and be done again. Beyond that, we can make a collection of functions and call it an object or a class. We can create a class that has its own methods, which are essentially class-based functions. Now, these will all be within the scope of that class itself, utilize variables within that class, but it also can utilize your global variables, which you've been making. But yeah, a class can hold its own variables, It can hold its own methods, which are just functions, and it can expand upon those things and be called within itself. And the reason we want to make a class is we can make multiple instances of a single class and have them doing different things even though they have the same code base. So for example, an enemy in a video game, even though there's dozens of them, most likely have a single class that they're based off of, and they create multiple instances of that class or that object to run those enemies in the game. So that's what we utilize classes for, is to abstract things even further, so we don't have to write code for every single enemy in our game. We can abstract out, have a class that has all the information in it and has those behaviors already programmed in. Then we can instance out and make copies of and then have them behave in the game. For example, string is actually a built-in class or object in Python 3, so it works just like a class. It has its own functions, it has its own methods, it has essentially variables inside of it that you can kind of utilize. So we're going to expand on our Hello World program that we did last time and show you how to use some string manipulation and escape sequences and other functions, just so you guys get an idea of how this works out. So if we run this like we did last time, as we can see, it says Hello World right here, and that was our application. So our application was run, we ran, it says Hello World, process finished with no problems. Cool. So what if we want to change this out? So we talked about escape sequences before. If we do \t in there, if we notice it lights up orange, we can see it's orange now. We don't have to really worry about knowing if it worked or not. So if we press our play button now, as you can see, this is now tabbed out instead of spaced out. Now what happens if I get rid of my spaces in between as well? So if I go ahead and get rid of this one and get rid of this one, let's see what happens. If we play this again, it also gets rid of our spaces. So before it was saying hello space tab space world. Now it just says hello tab world. It's a way we can space things out properly. Now let's say we want to do something a little different. Let's say we want to put it on 2 lines. If we did \n, we could do this. Hello world. Now N essentially stands for a new line, or yeah, essentially stands for new line. Now it's R just says world because it's a carriage return. So what R does is actually return us back to the beginning of the sentence and not return us to a new line. So previously it used to be \n \r on old typewriters, and that's what these kind of represent, is a new line going down and then R to return. But most computers in Python treat new line as actually a return and a carriage return. So a new line and a carriage return. So you can utilize just \n or \r together, or just \n. Another one you could do is the double backslash. If we run that now, that actually will put a backslash between our characters. Single backslash or double backslash show the same thing. Now, here's some other things we can do. We can do single quotes instead of double quotes, and it still does the same thing. So there's 2 different ways we can do quotes. So if I do single quotes in here, I can now do double quotes inside, and it shows me those actual double quotes. Another way we could do this is if we did backslashes on both of these, it will show me those. So let's do an individual one. If we just did an individual one, it will show up. But if I didn't have the backslash in there, it ends, and you can see it's a syntax error, it ends my string before world because we didn't have a backslash in there. Now we do. So we can show it out. So what if we want to do something else? What if we want to do this? Let's expand this out and do it a variable. So x, we'll just start as x, and then we can notice it's a variable because of blue, equals, and we want to do our string hello world. Oops. Yeah, that's correct. Hello world. Now our print statement, let's just say x. So now we're going to print x. If we run this, it still says hello world. If we get a period on here, we do a couple periods, hello world ... and now it's hello world ... It allows us to change some things. Now what if I did this? We say hello world. Now y equals, let's see, actually y equals world, and x just equals hello. If we do that now, it just says hello. But if we do print x comma y, we actually get hello world again. So there's a lot of interesting things we can actually do with our built-in functions and variables. Now here's something really interesting. I'm going to multiply our hello by 10. And if we notice, there's no syntax errors right now. This is absolutely correct. So we have our expression on this side that equals, or is assigned to x over here. If we run this, now it says hello world. If you notice, there's no spaces in between. It just repeats hello 10 times. If I want to add a space in there, I can, and I run that. Now it says hello, 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 hello 10 times, double space, and then world. Now if we notice this x right here, the x comma y, it automatically applies a space to us. What we can do in here though is instead of doing the x, we could do a plus sign in between, and it gets rid of that space because we are no longer printing out two different things with a comma separated value. We're actually adding them and smashing them together. So there's no space here at the beginning of the world. So it's just adding those two strings together. So we can actually add strings together. We can do another example of saying z equals x plus y, and then only printing out z. And running that, we still get the same results. So what I want you to do is look over and see how you can play with this. We've got some other really cool built-in function as well. For example, we have len. Length essentially, len, L-E-N, essentially gives us the length of something. So if we did length of x and printed this out, if we wanted to print length of x out, we could do that and run that. Now we have our hello world 10 times, or the hello 10 times, world once, and then it prints out 60. So it's counting, there's 60 characters in this hello. Now if we get rid of our times 10, it should reduce us down back to 6, because we have HELLO, which is 5, plus our space, which would be 6. And that's why we had 60 prior. Alright. After that, there's a couple other things cool we could do. Let's say we don't want it to say hello world, and we want it to kind of respond to our players, or our individuals. We don't really need to count our length of our hello world anymore. But what we could do is say input, and we want a prompt. So a prompt is essentially a string what's going to show the user. And we're going to say, let's do, what is your name? And what we're going to do is actually store this in player name, or pname. So we have pname, assignment equals, input, what is your name, as a string. And then what we can do is now print, say, we're going to tell them hello back to them. So like I showed you already, we can say hello, instead of hello world, space, plus, or we can actually start with our x instead, do our x plus pname. We can do that now. So we print this, so it says hello world, what is your name? Now it's asking me to type, so I need to type something, Travis. So I'm giving it the word Travis. It says hello Travis. Pretty cool, huh? One thing that this happens though is whatever we type in for this input comes back as a string. It assumes it's a string. So using another built-in function, we can say age equals input, one's a prompt, what is your age? And again, we want to print it back. But let's say we wanted to represent it as a number, an integer, instead of representing as a string, right? So we can still print it out. We can say print age, and let's just go ahead and give it a constant string. Your age is colon, and let's put a space at the end, and then we want to do actually we don't need a space, we can do a comma. We're going to do your age is, and then put your age in. We can run this now. So I'm going to type Travis. Hello Travis, what is your age? I'm going to put 500. And so your age is 500. It came back correctly. So let's say we want to take the age and actually do some math operation with it. As we showed before, if you do math with a string though, it just repeats the string. So what we need to do is actually convert this over to we need to convert this over to an actual integer. So for example, if we did this at first, say like age in months, we did age in months, and we said age times 12, we'd essentially get something still. We print this out, it's still technically correct. It's syntactically correct. Name is Travis, age is 500, So it still says age is 500. It still went through the math operations. And if we do age and month instead of age, and we do this again and say, what is your name? Travis. Age is 500. It just repeats 500 12 times. We don't want that. We want actual math to happen. What we have to do is use a built-in function called an integer, or our int, integer, and cast our string into an integer. So what that will do is look through the string and find the integer and pull out that integer value. So there's two places we can do it. We could do it here around the age and cast it, and then continue storing age as a string, or we could do it directly around this input and do int for int, and then put parentheses around it. And what's going to happen is the input function is going to bring in the string as the internal function. Then the external function int, integer, will actually cast that into an integer, then store it into age. Then down here, age will be multiplied by 12 and then be stored into age and month. So now we can go, your age is age and month, comma, in months. So if we do this, hit play, what is your name? Travis. What is your age? 500. Your age is 6,000 in months. So that's a really cool little trick you can do. It helps you a lot when you're first starting out. So I want to make sure that you guys are playing with this and having a lot of fun, and I hope you get to learn some stuff.